This is help with the vertical motion model. In this video, we're going to look at how to find the time when an object is thrown. In that case, we're going to use the equation h equals negative 16t squared plus vt plus s. H is your starting height, t is the time, v is the velocity, and s is the starting height. So let's read through the first problem. A paintball player was shooting at targets in a raised fort. When he shoots, the paintball has an upward velocity of 300 feet per second, and it is shot out of a gun from a height of 6 feet. The enemy fort is 40 feet up. How long will it take for the paintball to hit the fort? And are there just 2 chances or 1? So as we read through this, I went and picked out all the important information. My h, or the ending height, is going to be 40 feet up when it hits the fort. The velocity is going to be a positive 300 feet per second, positive because we have the upward velocity. And the starting height is going to be 6 feet. So when we plug it into the equation, we have 40 equals negative 16 t squared plus 300t plus 6. Now, there's 2 ways we can solve this. Way number 1 is we can use the quadratic formula, in which case we need to rearrange this equation a little bit. Make sure it's in standard form. Everything is on one side of the equation. So I'm going to subtract 40 from both sides. That way I get 0 equals negative 16 t squared plus 300t minus 34. From here I can identify a, b, and c. A is negative 16, b is 300, and c is negative 34. From there, we will plug it into the quadratic equation. So t equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And the equation we get is negative 300 plus or minus the square root of 300 squared minus 4 times negative 16 times negative 34 all over 2 times negative 16. From there, we're going to go through and simplify. First, I clean up what's underneath the square root. So if we start over, t equals negative 300 plus or minus the square root. In my calculator, I'm going to type 300 squared minus 4 times negative 16 times negative 34. Hit enter. And the number I get under the parentheses is 87,824. And that's all over. I'm going to clean this up a little bit. 2 times negative 16 is negative 32. From there, this plus or minus tells me I can split this into 2 separate equations. So my first one is going to be t equals negative 300 plus the square root of 87,824 all over negative 32. And then the second equation is going to be t equals negative 300 minus the square root of 87,824 all over negative 32. This next part I'm going to do all on my calculator. So I can type in the numerator as one thing, open parenthesis, negative 300 plus the square root, that's the second x squared button, 87824, close the parenthesis for the square root, close it again to enclose the numerator, and then divide everything by -32. When I hit enter, I can find one of my times, if I round to the nearest hundredth, is 0.11 seconds. So then I'm going to simplify the second equation. Again, just type it all into your calculator. Open parenthesis to enclose the numerator. -300 minus the square root, 87824. Close parenthesis once for the square root. Close it again for the numerator. And it's all divided by -32. And I hit enter. Again, rounding to the nearest hundredth, another time I have is t equals 18.64 seconds. So in this case, if I look at both my times, they're both positive, they're both something that could make sense. So this problem is going to have two answers, or two chances for a paintball to hit the fort. At t equals 0.11 seconds, and when it comes back down, at t equals 18.64 seconds. Now, like I said at the beginning, there is another way to do this. Way number 2 is using your calculator. So if we go to our calculator, we're going to go to the y equals. In y1, I'm going to type 40. In y2, I'm going to type -16 t squared plus 300t plus 6. So we type this in, 40 and -16. Instead of t, I'm going to use the x squared plus 300x plus 6. Now looking at this, I know I'm going to have to shift some things up and down. For example, this 40 is going to sit way above the graph, somewhere up here. So if we go to our window, the y max, I'm going to change to 50, just so I can include the y equals 40 and I can see everything a little bit better. Since I am adjusting it up so far, I'm going to change the scale to a 5, just so I don't have it as blocking. Hopefully I can see a few more things. And then we hit graph. Alright, so unfortunately I can't see everything that's going on. Looks like the parabola is starting right here. But either way, if my algebraic answer is true, t equals 18 seconds sits somewhere to the right. So now I'm going to go back and change the x scale. Just go into window again. I need to go further to the right, so that's y max. And I'm going to change it to 30, just to make sure. Since I changed it to 30, we can change the x scale. I'm just going to change it to 2. Hit graph again. And now we can see the parabola a little bit more. It's not perfect, but what we're looking for are the intersection points, which I can see both of them right now. It's kind of hard to tell, but the parabola starts right here, goes up, and comes back down at some point. So in order to find the intersection points, we use second trace, 5 for the intersection. I'm going to scroll as close as I can to the very first intersection point. Hit enter 3 times. And it tells me the intersection is 0.11, comma 40. So if in my notes, I'm going to sketch my graph real quick. Here and here. Looks something like this. Doesn't have to be perfect. That's y equals 40. This first intersection point is at point 11, comma 40. If I want to find the other intersection point, use second trace, 5. Scroll as far as you can to get to the other intersection point, or as close as you can to the other intersection point. Hit enter 3 times. And again, it tells you it's at 18.64, comma 40. So our solutions here are going to be x equals 0.11 seconds and x equals 18.64 seconds. The exact same thing we got with the quadratic equation. So it does not matter which method you use, it's whatever you're more comfortable with. In this case, it was kind of hard to see the intersection point. So maybe the quadratic equation was a little bit better since it gave you such a small number. But like I said, it's up to you whichever you use.